are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight on various domains. The topic of today's session is securing mobile applications, and we have with us Mr. Chakri Devarakonda. He is a Senior Manager Global Delivery at Cigniti Technologies. Chakri has 13 years of experience in the field of security testing and security product testing. He was instrumental in establishing and growing large security testing practice. His areas of specialization are development of various security service offerings, mobile security testing, web application penetration testing, product security testing, and PCI DSS compliance and network security assessments. We also have with us today Mr. Sairam Vedam. He is the Assistant Vice President for Marketing at Cigniti Technologies. Sairam has more than 14 years of experience spanning both software products and services in a variety of roles from engineering to management. He drives marketing and branding strategies for the company's rapidly expanding solution services, IP-led marketing leading, game-changing testing services set across domains and technologies. He is also responsible to have positive results and influence on the entire brand, touchpoints, customer, prospects, investors, analysts, employees, prospective employees, and management teams. So without any further delay, let me quickly introduce you all to our first speaker today, Mr. Chakri Devarakonda. I would hand over the session to Chakri. Over to you.
Yeah, so very good afternoon, everyone. This is Sairam. Just a moment. On behalf of Cigniti, we take this opportunity to welcome you all to this webinar. Cigniti is world's third largest independent testing services company. We've been in the business since the last 15 years, serving global enterprises and independent software vendors across technologies and verticals. We set up test centers of excellence, offer high-end test process consulting, and do anything and everything around software test lifecycle. We believe in what we call the IP-led testing services, where some of our test engineering ideas have been resulting into patentable Cigniti smart tools which complement the existing market tools and accelerate customers' test life cycles by offering unparalleled advantage and quickening the return on investments and QA initiatives. We also bring in a very holistic approach in terms of setting up comprehensive test infrastructure labs. We probably have India's first exclusive robotics test labs. We have co-branded enterprise mobility labs with HP, a cloud-enabled performance lab, and with 95,000 square foot of space, offices across Hyderabad, Dallas, and Toronto. We are also the world's first CMMI SPC 1.3 certified organization, and we take a lot of pride in kind of contributing to the test thought leadership through a series of initiatives that we work around. Last but not the least, as an organization, we are also committed to the society. We do compelling work around the corporate social responsibility with an initiative called Project Significance, aimed to impact 1 million+ lives through education as an enabler. That's a little bit background about Cigniti, and I have the pleasure of handing it over to Chakri, who heads our security testing practice, and I'm sure the next 15 minutes is going to be enthralling for all of us. Thank you so very much.
Thank you, Sairam. Thanks, everyone. Good afternoon, everybody. I'll take you through the tour of how do we have to secure mobile applications from a testing perspective and also from a development perspective in terms of how typically developers do develop secure mobile applications, and how, as a test engineer, we would need to look at it from the developer's angle. Though most of the work shown the slides in the next slides would be related to the development stuff, but however, I would also give you a quick overview of how, as a test engineer, a security test engineer, we need to look at it from the angle. So this is the agenda in terms of what we would go through in today's session. I'll, uh, I'll I'll skip the first two slides because we know the abstract the speaker profile. I'll give you a brief overview of what would be the benefits of this particular session, and then also give you the importance, the paramount importance of why mobile applications need to be secure today with the start of the analyst speak. So that sets up the tone for this particular presentation, like why are we looking at mobile applications being secure and why today in today's world it's actually a very important stuff. And then later I will look you through on the mobile architecture considerations in terms of how a typical mobile is set up and what are the architectural considerations you have to take into while looking to an app in terms of from the developer point of view, how do you look at it and developing it, and from a testing point of view, how actually you have to test for it. What are the key entry points on it, and then we would quickly look through what are the different mobile threat agents in the architectural considerations and also how they impact us today in the security world. Then we would go ahead with the OWASP top 10 mobile risks, which is actually more intended towards what the OWASP is talking about, and specifically in terms of it still is a risk, it's still not a vulnerability, it's not called as a vulnerability because OWASP is still under the process of actually putting out a project for the mobile area and what are the significant risks of it and how the OWASP generic web top 10 comes into picture. And in between, I would quickly go through also the iOS assessment, like in a typical iOS way, how the assessment has to be done from the security testing standpoint, what needs to be looked upon, the typical data flow, and what are the typical entry points. And then the final one would be what are the different phases of a mobile security testing. And it's more of a summarization slide for what we have actually looked at for this particular presentation. So moving forward to the abstract slide, where I would key upon why actually we do need this and why smartphones and mobile internet have been the actual stuff where it is being looked upon as the convergence medium for all the interfaces, and we would have this more in terms of what it is from the standpoint from an analyst, so that we could specifically look at it today, how the analysts are having a look at the mobile world. And the typical benefits of this particular session is that, as I said, we will understand what is the threat landscape, what are the vulnerabilities of a particular mobile application. I do calling it as a vulnerability, though OWASP calls it as a risk, but however they still see as a vulnerability for us. And how does a mobile attack happen? What is the anatomy of it? When we talk through the top 10 risks, we understand what is the anatomy of a mobile attack. And we would also understand how a security testing of a mobile application actually is performed and what are the key considerations to be taken at the end of the day. So moving forward on the analyst speak, the key analysts Gartner and Forrester, as you've seen in the slide, talk about how specifically when you go around a decade back, most of our devices would be actually being owned by the enterprise segment. That is the corporate itself would give us the devices, and the typical BlackBerries where the encryption standards are pretty high, the kind of applications being leveraged are low. Typically a phone is more used towards sending secure emails, kind of thing. But however, today with the BYOD, bring your own device standard, which has come into perception, and which it has come into actually existence today. Every person, every single employee would have a different device, whether it's an Android, iOS, BlackBerry, and couple of other new operating systems which are being given birth in the mobile space, actually makes it pretty difficult for any corporate to govern the security policies on it. At the max, you would have a typical 4-digit PIN for a particular thing to access your email, which can also be circumvented by using different application settings in terms of you can still unlock the device for the next 15-20 minutes. If you don't, it gets locked only after 15 to 20 minutes, say max 15 minutes in an iPhone. So that itself brings into a lot of existence in the security world for the vulnerabilities in terms of when you leave the device unopened or unattended. Definitely people would have an understanding of what are the different types of emails you send, what's the corporate stuff. So basically it's more of like testing this would be a little difficult because physically the data is available with us, it is on the go, and in terms of specific challenges exist, like you would specifically know where is he available right now, what is he doing, what are the sensors available, the gyro sensors of a particular phone can also be tapped upon. If you have an app which is malicious, or if you have an app which can pose an entry into your device, which we can specifically talk about in the next coming slides. But however, the ownership of the device and the data which resides is also calls for the privacy standards currently, which has to be taken care of in a compromised device. So, and as I said, there are a plethora of devices, different operating systems. Specifically, if you take an iOS or an Android, it's still getting better and better today in the security world. But we never know. A new operating system can always bring up a lot of things, particularly with emergence of iOS 7. There are so many things which can be brought into table, which would be looked upon for specific vulnerabilities. So in terms of, as you see, the summing up of us is that due to the convergence of the media to mobile, where the mobile is not specifically used for a phone or a phone call, it can does a lot of things. You have social media convergence, which actually gets into a situation where all the social data of yours can be put up from the corporate data. So there is no specific in terms of you can't draw a definite line in between a personal data and a corporate data, which actually brings a lot of problems to the corporate governance in terms of posing a security to the mobile device itself. So having said this, I've summarized the analyst's speak in that that gives a lot of things into perspective, that why mobile application security is very much required. So setting that tone, I would move to the next slide. Which talks about the architecture considerations of a mobile device. Typically, when you see a difference between a desktop and a mobile, desktop would have or the server side of it, where the web part of it is only specific when you get connected to internet. But from a standpoint of a mobile, you have a lot of architectural considerations which needs to be taken care. What are the typical different types of wireless interfaces it has? What are the different types of transmission types it has? So when you talk about typically wireless interfaces, you talk about Wi-Fi, which is the 802.11 standard. Then you have the near field communications, the NFC. You have a Bluetooth. You have an RFID. So there is a plethora of entry points and exit points to the data to be actually looked upon. primarily what do we try to secure in a particular application? It is the data. At the end of the day, the data is governed by the CII trade, the confidentiality, integrity, and availability triad. So when we're talking about these three triads, it's more about how secure or how confidential is your data, whether the data you have is actually the right data, and whether the data which you need to have it, which is the availability part of it, is it there with you. So in terms of that way we talk about it, the exit points and the entry points for a mobile is very high. And when we talk about specific hardware interactions, as we when we were looking at the analyst speak slide, they were specifically like you have access to sensors, accelerometer, which will talk about you whether you're in motion or whether you are standing or sitting, because most of the time your mobile is in your pocket or in your hand. So they would exactly know where your position is from the geolocation, that is the GPS, and the other communication hardware components like GSM, CDMA, LTE, which all provides an interface for it. And at the same point of time, all the most of the mobiles do have, with an exception of Apple, do have an SD card interface. So SD card, that's where is the removable storage. So what kind of information can be stored in the removable storage would also be a part of it. And also, we do need to understand that typically a phone does have access to a microphone and a camera. So what happens if somebody is able to click a picture out of your camera from sending an SMS to you, which gives you a control to the camera application? There are specific applications where you would specifically give, it's more about talking about luxury versus security. So when you want to have a luxury of where are you, where is your buddy available right now, with the geolocation sensor, with the GPS, you would be able to find him. But at the same point of time, imagine a situation where that application is being able to be hacked by somebody else, and it would give you a situation where some other person would actually know where your location is. What kind of activities are you doing right now with the help of your camera? So these kind of stuff would actually give us, in terms of when we are designing an application or when we are testing a application of a mobile, for the mobile, we need to be really careful about how do we look at these points as entry points and what kind of information can we look upon it. So in terms of the other part is the interaction with on-device applications and services. Let's take the same example. If you have a native application and an application is able to access your SMS or your address book, so that means itself a lot of information available to the attacker or to the person. So in today's world, nobody is actually acting upon the information they get immediately. Nobody attacks immediately. They do get a lot of information, they gather a lot of information, and they would make sure that that information is useful at the point when it is necessary. So that's where we need to be very careful in terms of getting the corporate address book. So the email syncs up with the corporate address book to your phone. So what happens if the corporate address book is lost? You would initially get a lot of addresses of the organization, the top management, which would actually can be used in any manner. So, and in terms of interaction with off-device application or services, where is being stored? Typically, when you take a photograph for the kind of luxury, you send it to a Dropbox or a Picasso or a Flickr, or a Twitter or a Facebook. What happens if in this, when it is being cloud synced, the data is secure or not? We never know whether the data is being secure from the cloud perspective. So having the luxury and the comfortability from a standpoint of when we talk in security language, usability, that's a big problem or a big challenge being posed to any particular developer, and at the same point of to the test engineer to look at it. And what are the key encryption protocols are they using? Are they using something which is available from the iOS stack or the Android stack, or are they building up their own? Or they may really say that I don't need an encryption because we don't have any information to be passed on, which is not really important. But the point is, like, when you club it with something else which is importantly available in the device, which can be accessed upon, that point of time the encryption protocol gets into a paramount importance. So these kind of considerations and architectural issues should be looked upon. So that way it gives us a real understanding of how do we test the mobile application, and at the same point of time how do we actually develop it. So typically moving on to the next slide, which is the threat agent slide. When we talk about threat agents, specifically I want to also emphasize on what kind of things we do in terms of specifically we need to understand what is the business function of the application, what data does that application store or process, and what is the data that can give to the attacker. Either it is at rest or it is at transit. So rest is in terms of when it's stored in the device, where is it stored, how secure it is. When it is in transit, how it is being transmitted, and what kind of information is being transmitted, and whether the application will have access to any particular private data. So the privacy of the user is also at large, because definitely when an application can have access to something else, it can also have to a personal data, and whether how it is sandboxed. And the major problem or challenge is that most of the users, for the sake of convenience, they do jailbreak their iOS devices or root their Androids for getting the immediate or the available ROM, which is still not available in the market, but currently which is being spent through by different people. So that way what happens is like this would affect how the application is behaving, because specifically when you jailbreak a device, jail is nothing but jailbreak. If you break that into two words, it's jail. It's what they're calling Apple as. They are putting all the applications in a particular stuff, and you can't use it because as Android gives the convenience of you to have so many different types of icons, colors, themes, and all that. iOS doesn't give you. So synonymously, they have put it as the Apple and jail, and you're breaking it. So you're breaking the ice from there, and you can do anything with your device. Typical way of looking at it from a user standpoint, yes, since I bought the device, I want to do anything else. But today it's not the case, because you are actually at an issue in terms of when you take it, when you are unsecuring your device from the, or you are letting away from the shackles of the security, which in fact you are putting up into a easier perspective to the attacker. And the rooted device for an Android, the rooted is nothing but gaining Android is based on a Linux shell, and rooting is nothing but gaining the root level access or the highest level of super user access, where you can do anything with, you can actually get any application, any permission for a particular thing. So your underlying system is being accessed upon. So talking about the different types of threat agents, specifically the available, you have a malicious SMS, which can actually give you a kind of situation where you would definitely have some information being stolen by clicking a particular link in the SMS what you've got, or you have a specific malware on the device which is actually accessing your application, which it should not be able to access upon. And you have a malicious developer who has written a particular application which is actually, you see it as a simple calculator, but at the end of the day, the calculator is trying to get some information out from your mobile device. And a typical app store approver or reviewer, or who fails to actually review a particular code or a malicious application, so that will give way to user's device in terms of it. Any stolen device, yes, any stolen device will have a lot of information, sensitive information belonging to the owner of the device, so that way it is actually a problem to you. and any script, in terms of script executing in the browser with the HTML5, so any script code which is being written in a language similar to a JavaScript can be executed, and which actually can rip off some information from your mobile. So these are the different types of threat agents what typically you have in a mobile device, which will not be which all of them will not be a part of it in terms of when you talk through a web, because if your desktop or a laptop is stolen, you might have an encryption methodology which is securing your file system, or your corporate government has allowed all the information to be stored on a secure server rather than on your device. So that can actually give a lot of confidence to you, but you never know because nothing is being actually looked upon on a typical mobile device. So moving to the next slide, in terms of the OWASP top 10 mobile risks. As I said, typically when we talk about vulnerabilities, OWASP talks about the top 10 vulnerabilities. But however, we do talk here about the top 10 risks because they have not been yet classified as a vulnerability, and that's where we get into a kind of stuff that definitely these are still risks. So we'll go through on the top 10 risks where in detail in terms of what are the different types of risks. As you see, there are insecure data storage, the weak side server controls, insufficient transport layer, the client side injection, poor authorization or broken authorization and authentication, improper session handling, security decisions via untrusted inputs, side channel leakage, broken cryptography, and sensitive information disclosure. So moving on to the insecure data storage, which talks about typically I'll explain you what the slide contains about. This is the typical slide content for all the other 10 top 10 vulnerabilities. We talk about a threat agent. So what is a threat agent? Where is the threat being come from? What are the attack vectors? How is the what are the different types of attack vectors we have? What is the exploitability you have? Is it easy, or what kind of exploitability has it? And what is the security weakness, whether it is a prevalent weakness, whether it can be detected that the weakness is available, and what is the technical impact. We do also have a business impact, which typically depends upon what kind of business flow we are into, which has to be looked upon. So as a security test engineer, we cannot say specifically that we have a vulnerability, we have a risk, it's a high one. So how do we classify it as a high, low, medium? So a lot of math undergoes in this particular stuff, where we talk about how easily is it attackable, exploitable, in terms of how easily it is exploitable, and how is there a proof of concept where we can actually say that we can fix it, or is it in terms of it's an unconfirmed stuff. And when we talk about when we do this, we get into a common vulnerability scoring system, which is typically the version 3 in the beta mode, but we do take the beta, the 2 version, which is more rock solid, and give a scoring system to it. So that way it gives us more information on it. So moving on from that, in terms of what are the insecure data storage? When we talk about insecure data storage, how is the data being stored in the mobile for that particular application? So maybe when this particularly happens, when the developer does think about that there is not much of information available in this particular application, and at the same point of time, this application can be stored in a phone file system, so that way nobody has access to it, or a file system which is not really breakable. But typically when you do a routing or a jailbreaking of a particular device, that would actually inflict the problem where it says that the application data can be hooked up to a particular laptop or a phone, and we can have information onto it. So the threat agents would be the stolen devices or the lost devices, or a possibility of a malware in the device, in the phone, or an application which is behaving maliciously for it. So that's where it gives you more of information. That's why it gives you more of information, and the impact would be very severe in terms of whether the authentication is impacted, the personal information. If you store credit card data into it or an application data, that would be lost to the attacker. Moving on to the next slide, where are these usually available? What are the usual suspects of it? Where do you get this information? Specifically in SQLite databases, log files, the plist files, the cookie stores, SD card, wherever the cloud sync is happening, or the metadata files or the manifest files, which are known as the typical usual suspects for us. So when we move on to the next slide, typically for a couple of the vulnerabilities or risks, we have put on some best practices with respect to iOS and Android. However, with Windows or BlackBerry, we haven't yet done something. So with respect to the iOS, when we talk about it, we never have to store the credentials on a phone file system. You have to specifically use a standard authentication, web or API login authentication to the user over a secure channel, which would allow us to make sure that there are proper timeouts and session management happening, to make sure that we have all the information in place and every information is not being accessed upon. So in terms of when you feel that the data is very small, you can use a keychain API, but as I said, once the phone is jailbroken or exploited, you can specifically have access to all the keychains. And for the SQLite, you can have a data encryption or an SQL cipher, using an SQL cipher, which would actually keep all the data encrypted. And for the items stored in the keychain, we have to leverage the secure API designation, so that way we have information on it. Typically, now the devices are able to enforce the strong PIN, not the four character stuff, but also multi-character, which would allow us an alphanumeric one, which would allow us for more secure authentication. And in terms of use the Apple's file protection mechanism, which should be used upon, so that way it will help us out in terms of doing stuff. And we talk about Android specific best practices. As I said, in terms of the specific device administration API, should be used to force encryption to local file storage, where you can say specifically set storage encryption. And for SD card storage, you can use a Java crypto library, which would also give you some kind of security in terms of it. So ensure you would also make sure that all the properties are not word readable. So that means you don't store it in the file system where it is pretty easily readable. So one of the key takeaways for the security test engineer is that he looks upon these particular places whether the usual suspects or what are the best practices have been passed upon. So when you know how the development team does the development of an application, whether it is secure or not, the test engineer can look through it by seeing whether the best practices are being followed and whether the usual suspects for this particular risk are they available or not, or are they being actually properly secured. Moving to the weak server-side controls, the second risk, which it is specifically this threat agent applies to the backend services. Here we talk about whatever at the end of the day the mobile device gets synced up with a web server or with a server-side control. So the mobile might have an interface to it, and if it is a mobile web, the mobile web will still go and hit the server side. So primarily any kind of vulnerability for the OS top 10, like the SQL injection, cross-site scripting, these all fall into place for this. So the weaknesses for it is typically the web world weaknesses. Since we know specifically that these weaknesses have been existing from the last 2005, so around a decade back, we are now secure enough to understand it, and we don't repeat the same mistakes. But as a security test engineer, we need to look through it's not granted that we don't need to take it for granted that the web application vulnerabilities have been secured, so there are no vulnerabilities on the web side of it. Typically, you have to check for an XSS if it is a field is available, see whether the validation is being happening in the right perspective or not. Whether it is a SQL injection, whether you are able to access the databases through an injection method. So typical impacts of it is your confidentiality is being lost, your integrity of the data cannot be trusted. So the business impact for this specifically is that loss is always there for the brand and reputation. So when you talk about it in terms of looking at it from the business perspective, the brand reputation is at a large from typically from a mobile standpoint than from a web standpoint, because a lot of things from the mobile, it's pretty easy. As soon as you download an app, you look through it, you have a lot of people accessing the mobiles, and once the number of people or the population being accessing the mobiles is pretty high. So that's where you would look through it as the impact for business is pretty high. As I said, the usual suspects, check for all the web top 10, the cloud top 10, look for it because web is a part of it, and also cloud because a lot of things get synced to cloud from the mobile standpoint. So check both of those, that would give you a stuff. As I said, the prevention tips in terms of make sure that what is the application being done and what it is actually bringing onto the table, and whether the backend API services or the platform are secure enough, and all attack vectors, because all the attack vectors are from the web world and the cloud world, so we are all well known for it, so we need to understand it in a much better perspective. So moving on to the third one, the third risk, the insufficient transport layer protection, which is typically where you have a lot of problems. When we talk about it, the insufficient transport layer protection, the applications, there are a couple of applications which are devised went through a 3G, they say that you go through a Wi-Fi or a secure, went to a 3G, you go through a secure connection, but whereas through an Wi-Fi, you don't go through a secure connection, because there is an assumption that all the Wi-Fi are secured. But currently, the way the mobiles are being used, you can definitely use it at a kiosk, you can use it at your airport, where there are no secure channels. or your cave, I don't think there would be any security in perspective in a cave where the Wi-Fi is allowed for free. So when your application typically switches from a 3G to a Wi-Fi, the secure connection will get switched off. So that way you are putting the data in transit in a kind of high risk zone. So these kind of stuff is pretty difficult to actually look upon, and these impact a lot of both from the technical perspective and the business perspective. There is a lot of impact to an individual and also to a particular organization, and specifically a lot of attacks can happen through this. So who are the usual suspects? In terms of the usual suspects are the connections, not you are basically owning it, the SSL certificates, whether they are date, are they self-signed, or they have the enough cipher strength, would you check for it, and any particular the application will accept any certificates as authorities. So whether they are following the right stuff is not, you have to check for, which is typically you as you check for a particular website. So moving on to the prevention tips, as I said, we need to enforce SSL and TLS at all transport layers, all transport channels. All stuff should be doing through a secured thing, and any third-party companies should also be using an SSL session, so that the user session ID should not be exposed at any point of time. Strong and industry standard encryption algorithms have to be put in place. Your security provider, the CA provider, should have a signed security, and it should be a trusted one. No self-signed certificates. Never ignore or disable SSL because for the lack of, for the comfortness or a kind of assumption that the wireless through the Wi-Fi it would be secure enough. And you have to, whenever you get an exception saying that this particular certificate is not valid, you need to take utmost care that yes, this should be looked upon, and no specific sensitive data should be sent through any particular channel like SMS or notification, where there is a possibility of getting the traffic getting sniffed and having more information to it. So typical best practices in iOS and Android which can be used so that we have a specific all the certificates being enabled. So if the certificates should be valid, and it should also be fail closed so that there is no issues on it, and all the default classes in iOS will handle very well all the SSL negotiation and cipher strength, so that can be used upon. And specifically for Android, we should remove all the code with the development cycle and allow the application to accept certificates from a host name which is verified. So that's how it has to be done in terms of the best practices. So moving on to the next slide is the client-side injection. This is typically when a particular SQL injection, how can it be happening from this part of it. We do test it from the second vulnerability or the second risk, but at the same point of time look at it on the client-side injection, how it has been happening, whether the server-side verification is happening or is it happening only at the client-side, the verification. So in terms of how the data is being injected for this particular, what is the source? Any source can be a data, any source of data can be an injection vector. So how it is being injected is we should be able to look for it. So we have to understand the injection attacks, and the impact would be depends upon what kind of application you're using and what is the data which is which it is trying to get. What kind of information it is being is it allowing you the user database from your any data being stored at your phone, is that being used, or any application, or anything which is being paid content is being accessed without your notice. So the usual suspects is the data on your device, the session, the mobile user session, and what are the interfaces or the function for that particular application. So specifically, iOS specific stuff, as I said, SQLite injection should be taken care of. All the queries which has to be parameterized. Whitelisting has to be done. No special characters can be included on a particular login form, so that we would have specific authority in negating those stuff. Look at different kinds of injections, JavaScript injections, whether they are being applied filter for it. Specifically, look for validation stuff. Whitelisting of it would be very, very good, so that you would not get any information out of it. And also, when classic C is being used, most of the old C functions are very vulnerable, and it is well known. So avoid to use these functions which are very, very vulnerable to the injections. And with respect to Android, the top three would still be the same in terms of SQL injection. All parameterization should be done. Anything it is, any JavaScript or plugin support should be disabled, or at any point of time whitelisting of it should be done, so that no specific characters will be get into it. And at the same point of time, local file inclusion is being disabled for web views, so that they don't have access to any particular local file when trying to view through the mobile web world. The fifth one, the poor authentication and authorization risk. It's basically why it is a poor authentication and authorization. Simple thing, it is because the application do not use strong authentication and authorization schemes. They do use your phone number or your IME number or your unique identifier, unique user identifier as the actual authentication purpose of it. So the whole purpose of the stuff is defeated. For example, if you are trying to get authenticated for a lost or a stolen device, and the SMS is being sent to your device itself, so it's already lost and you are being compromised. So you have the information, because you can quickly pick up your UID and send it, or the application itself picks up the UID or the IME number of the phone and sends a third-party token for you through an SMS, where your SMS is already being compromised. So this would actually give an information onto the attackers, and at the same point of time, we do have specific authorizations and authentication items which would make them fail, and the data being wiped out of the device. So that would also be a problem for us. So the usual suspect for this is typically the apps are left at the mercy of the mobile device. You need to actually have a strong authentication and authorization map, so that way it's not left at the mobile device itself, and never use the device ID or the subscriber as the sole authenticator. It can be used as one of the part of it, but it should not be used as the only part of it. So moving to the prevention tips, we would specifically implement the user authentication and authorization and session management correctly, and you have to authenticate all API calls to the paid resources. Paid resources in terms of any resource which you are paying for it, an application which is trying to access your Skype phone or something which you are currently used as a paid application. So at that point of time, it could definitely give a lot of it would actually give access to your paid resources, or at some point of time your app store purchases are being happening without your notice. Application, whenever you click something, it would be able to purchase an app store stuff, so that would also be a problematic stuff. So typically when we go into an iOS assessment, these are the things which we look onto whether the iOS assessment is being able to look for it. So we check whether how this application is mapped, what are the different kinds of client attacks it has, network attacks, and server attacks. Specifically, when you see what is the from the application mapping, whether it is what are we using from the platform, what is the application architecture, and how is the data flow happening. And from the client side, in terms of we need to identify what are the frameworks which are in use, server side APIs, what protocols are being used, and how is this present application or service accessing other applications or stuff. And when we typically come to a traffic analysis, we need to check what are the different types of error messages, what is being a cacheable information, what kind of transport layer security will place, how is it happening, how is the URL stream stuff, what is the push notifications happening. So when we talk about it, there are a lot of things which we need to check for a specific iOS device. So look at so in terms of all this, we have to look at how are the different types of things happening. So when you do a runtime analysis of a particular code, you have to see whether how is the file system interaction is happening, how do you disassemble the application and see what kind of information it is throwing throughout. When you analyze the application with a specific debugger, whether what are the objects are being in the memory and what are being called as functions and methods, and what are the runtime variables in it. And specifically when you see about data storage, what are the, as we said, what are the places where it is creating files, or how is the database being accessed upon, how is the file caching happening, how is the cookies being input into place. So all these kind of things give you a perspective of how an assessment of a particular application should be done from an iOS perspective. So this all gives you on how we typically analyze when we try to check for an application whether it is secure or not. So these are the couple of tools which are generically used in security testing. We have proxy tools specifically for binary protocols. You have proxy tools for HTTP and HTTPS, the web part of it, which is everybody knows about it, or the word proxy or the charge proxy. But we also have proxies for binary protocols like Mallory. And you can check the SQLite database client through SQLite 3 and specific TCP dumps, the OTools for object file display and kind of stuff. So all these are only couple of tools what we have put into perspective in terms of it. These are only a partial list of it for it, but we do have a lot of tools which can be looked upon for this stuff. So I'll quickly go through the other four mobile risks in place, which is the improper session handling. Specifically, session handling is not being done pretty well in terms of it, because the usability perspective of a mobile device comes into picture, where all the organizations who have developed the mobile apps do think about my mobile app should be the most usable mobile app. Because of the constraint of typing your username and password again and again will actually put in a perspective where you are defeating the security of the application by having a persistent token for the session management whenever it is necessary. But however, if we do implement different types of session management as we implement in the web, in terms of having some kind of control, authentication controls at regular intervals, which would help us in actually moving into a much better world. So the usual suspects, as I said, that it's persistent sessions, and you take a convenient route by making it more friendly and usable. Specific prevention tips, you see that you don't use persistent identifiers, use non-persistent identifiers, implement authentication and authorization, and session management as it should be in stuff. Then the seventh one is the security decisions via untrusted inputs. This is where you can leverage or bypass permissions and security models by malicious apps or client-side injection, which will actually impact our stuff, where you get into a data exfiltration or privilege escalation or consuming paid resources. A typical example where we can talk about it is a Skype iOS URL scheme handling issue, which has come into existence when a HTML or a script injection by a different application gets the attacker, makes the attacker embed an iframe, and the iframe actually calls up a Skype application, and Skype which allows this application, which allows this iframe to handle it, and a Skype call is being initiated without the knowledge of the user. So that way, specifically, this can be targeted when you want to hear to different conversations which is happening. So in the corporate world, it would be extremely difficult to have these kind of situations. So the application shouldn't have any kind of leverage, shouldn't be leveraged by any other application. So you need to have specific interpreters with minimum privilege levels. You need to have specifically, we get in mobile saying that, do you want to do this? Most of the time we say that we don't want to do it. We say that, don't ask me again. So that's where the prompt for additional user authorization is being killed out. Specifically, this is how it is. And from the side channel data leakage, this is specifically when you have a private data being stored upon. A typical example of it is a screenshot being taken by the phone. So when you open an app, a banking app, and you are able to take a screenshot of it, that would actually divulge a lot of information, and which is being stored in the gallery, or sometimes you put it up to a Picasso or a Flickr or your own cloud, or a Dropbox, you would have a lot of information being lost. And never ever try this in terms of logging any credentials to it. At the same point of time, you have in Android a specific mechanism known as swipe, which actually logs all the keystrokes. So if anybody has the keystroke logging ability, access to those files, so they would be able to get through it. So these kind of information should be made sure that it is not available. The ninth one is the broken cryptography. Cryptography is a pretty tough one to do it, because unless and until you don't use the proper cryptography, people think that encoding is encryption. Encoding is not an encryption. Obfuscation is an encryption. Just by moving around some characters, it is not an encryption, and serialization is not encryption. There are specific cases where the IMEID plus the MD5 digest is one of the token. So for the encryption, so that can be circumvented once somebody has access to your IME and can easily calculate the MD5 hash. So that way it is pretty tough to it. The prevention steps: never write your own crypto. Use the crypto which is available from the iOS or the Android people, and don't store anything unencrypted, and leverage the file encryptions and the security containers which are available. The last one is the sensitive information disclosure. Make sure that the application doesn't have any sensitive business logic. Any sensitive business logic can be actually looked upon. Any intellectual property shouldn't be exposed to it. So any application which is being installed on a mobile app can be put upon onto a desktop and see how it is being actually packaged and what kind of information it is there. So all the stuff should be available on the server. Nothing should be available in the app because it is easily accessible for reverse engineering. So don't store specifically any password or sensitive data. Keep proprietary and sensitive logic on the server. Never hard code a legitimately a password. So these are the specific prevention tips for the top 10 risks. Moving on to the last slide, in terms of the mobile security testing, specifically there are four different phases for a mobile security testing. The first one is the information gathering, where we actually try to understand what kind of application it is, what are the data sources, what it can interact with it, how is it being stored, how it is being transmitted. All kind of things should be analyzed properly, and that's where you build the threat attack model for each threat agent and see how it can be negated upon and how it is being well done. Then the second part of it is the static analysis. The static analysis is that if you have the availability of the code should be there for it. You do have the code, and if you do not have the code, at least you have the binaries. You look through it, what kind of information is available through the static analysis, through different types of code analyzers, which would give an access to how it is being put upon. And then you do a vulnerability analysis for all the top 10 vulnerabilities or risks which we have talked upon and see how it is being looked at. And then you publish the vulnerability in a report with respect to different, whether how was the business impact of that particular vulnerability, how is the technical impact of it, and at the same point of time, what is the security index of the application on a whole, and how is it actually affecting the CIA trade. So that pretty much sums about the mobile security testing, what we generally do. In terms of it, I do know that we have almost run out of time. I've seen a couple of questions being popped up. I will take those questions and send it in an email response as we are running short of time.
Thank you so much, Chakri, for that presentation. I've already shared around 11 or 12 odd questions. Request you to take in at least 5 or 6 right now, and maybe you can take up the rest offline.
Oh yeah, absolutely. So that's fine. So I would read the questions for Chakri. Let me see what I have on my screen. The first one is how mobile data storage is different from tablet data storage. I think that's a question that's coming up.
Yeah, in terms of mobile data storage and tablet data storage, both of them would be the same because they are being used with the same operating system, whether it's an Apple or an Android. So in terms of it, we do use the same operating system. So typically the data storage would be the similar kind of stuff.
Yeah, wonderful. So now let me take a question from Pradeep Ravi. What is the major difference between jailbreak and rooting?
So the major difference in terms of jailbreaking and rooting is jailbreaking is being used in Apple devices. As I specifically said in the presentation, that jailbreaking is that all the applications in the Apple device are very secure enough and they do not have access to any other applications other than which are being ported in the App Store. So specifically when you jailbreak it, when you're trying to actually get access to it, you have applications which are hosted by Syria, which can do a lot of customization onto your phone, which also brings into a lot of things into table because there are a lot of rogue applications which can get access to your normal specific applications and get it done. But whereas in routing, which is in specifically happening in the Android world, that's where it is in terms of where you have access to the route with the super user because Android at the end of the day is a Linux kernel, so you do have an access to the route. So that's the reason why it is routing, and primarily this is being done for devices where the ROM, the specific ROM which should be available, may not be available immediately for all the Android users.
Yeah, for the benefit of a lot of the audience, we can take this one from Jobita. What are the tools available for security testing for mobiles, and in particular, and which are the popular ones?
Yeah, specifically as I said, the tools, there are a lot of tools which can be available, which are available right now. The Mallory tool, which does the binary functions, the protocol levels stuff. You have the Charles proxy or the Burp suite, which does the web related stuff, and you have the SQLite injectionware, which checks about the SQLite database stuff. So as I've mentioned in there are a lot of tools which can be done, but these specific stuff can be taken care of it.
Right. So there is a question, what are the challenges in particular for native and browser-based applications?
Browser-based applications, when we talk about it, it brings out all the applications, all the web-related stuff which is already available. All the web-related vulnerabilities are already available for it. Whereas in a native application, when we talk about it, the native application, as you say, that how the data is being stored, how the data is being transmitted, what kind of, whether this application is being provided an access to any other application. So these kind of challenges would be specifically there for it, and at the same point of time, most of the applications do have also a hybrid perspective with the native and web at a combination. So that would pose more challenges because all the vulnerabilities existing in best of both of the worlds are available for us.
Let me take the last two questions. One from Navina Raj. Can we use the apps which are sort of threads which extract the data from the mobile to find a lost mobile?
In terms of what is the specific usage you are looking at it, that is very important. So yeah, we do know that your ideology is to actually find a phone, but we never know whether the authenticity of the application is there. So if it is an authentic application, we can specifically look at it, but if it is not an authentic application, there can be a backdoor or a rootkit which can be installed and you can have the information of it.
I think this is a very interesting question from Akshay Doshi, who is left though. A mobile bank application sends an in-app message for authentication of the mobile number. Is this a secure method?
It defeats the purpose because at the end of the day we are trying to use a two-factor authentication, but the two-factor authentication is defeated when your mobile device itself is lost or stolen, because the person would get an access to the SMS itself. So it's as good as you have all the information to be used upon. So specifically something else can be done where maybe a challenge question can be asked upon which the attacker may not know, and he would fail in getting access to it.
Right. Let's take this as the last one from Kavipriya. While receiving virus-affected emails over any phone, what is the chance of the applications in the phone getting affected?
It's a good question. In terms of it again depends upon what kind of virus we are getting into it. There are a lot of viruses currently in market which are more of a phishing stuff rather than a virus, because it's sending as an act. Like for example, it asks you to click an image or a link and you would try to click that. So through it, it would try to get information of your particular phone, let's say an address book or an your SMS list log. So that's always poses a threat when we are not really sure what kind of it is. So at the end of the day, due to the technology advancement, virus emails are becoming more of a phishing emails and stuff where we do not know the authenticity of the user.
Right. I think pretty much we've tried to cover the buckets of questions that can comprehensively cover some of these categories. While we say that we would be more than welcome to take questions offline over emails, with that I think we are glad that we've got this opportunity and we thank TechGig and also a very intense audience who've been asking some very good questions. Thank you so very much.
Thank you so much, Sairam, and thank you so much, Chakri, for taking those questions. Um, we do have more questions, which obviously I couldn't share with you due to shortage of time. But as you said, the attendees can take up these questions with you guys offline. And yes, thank you once again for the presentation. And attendees, I hope it was an insightful one for you all. The recorded version of today's session will be available on techgeek.com by tomorrow. So you can go visit techgeek.com for the slides there. Thank you once again, Chakri. Thanks again, Sairam. It was a pleasure having you on board.
Thank you so much. Yeah.
Yes.
Intense one.